Last episode, we squeezed every drop of behavior out of one fixed model with the sampler. Today, we change the model itself, we make it bigger. And it turns out bigger obeys a law you can plot on graph paper and extrapolate. This is the law that justifies billion-dollar training runs. Here is the surprising part. As you grow three things, parameters, training tokens, and compute, the model's loss falls along a straight line on a log-log plot. Straight, which means you can predict how good a model will be before you train it. That predictability is why labs are willing to spend a fortune upfront. But how should you split a fixed budget? Early work said mostly buy a bigger model. Then the chinchilla paper corrected it. For a fixed amount of compute, grow the model and the data together. Roughly 20 tokens of training for every parameter. A 70 billion model trained on enough tokens beat a 280 billion model at the same compute. GPT-3, it turned out, was badly undertrained. There is a clean formula for the bill. Compute is about 6 times parameters times tokens. 6 ND, that is all you need to estimate the flops for a training run. And to see the trade-off, for a fixed compute budget, every extra parameter costs you tokens and vice versa. And here is the 2024 twist that changed the industry. Labs now deliberately overtrain. Smaller models on far more data than Chinchilla says is optimal. Why? Because training happens once, but inference happens forever. Llama 3's 8 billion model saw 15 trillion tokens, almost 2000 per parameter, 90 times Chinchilla. A small overtrained model is cheaper to serve, and serving is where the lifetime cost lives. Let's plot it. Loss on the vertical axis, training compute on the horizontal, both log scale. On this frontier, every point is a compute optimal model. Now drop in GPT-3, it sits above the line, off the optimal frontier. It spent its compute on parameters and starved on tokens. Drop in Chinchilla, it sits right on the line. Second panel, tokens per parameter over time. Chinchilla optimal is 20 to 1. Llama 3 8B is almost 1900 to 1. Qwen 3's small model is near 60,000 to 1. The bars climb, the industry is overtraining, hard, on purpose. Now the honest part, some abilities seem to switch on suddenly past a size threshold. People call this emergence. Left panel, accuracy versus scale. A sharp jump like water boiling. But measure the same models with a smooth metric, per token loss instead of all or nothing accuracy. And the right panel shows the capability rising gradually all along. The jump was partly in the measuring stick. So, capabilities really do grow with scale, but be skeptical of the word emergent. Mark this figure illustrative. We now know what an LLM is and why scale works. Last question of the foundations. How does a raw predictor become a helpful assistant? See you there. Thanks for watching. Like and subscribe for more videos like this, and I'll see you in the next one.